If the definite integral from -2 to 2 of x to the 7th plus k dx equals 16, then k equals what value? So we're going to have to use our fundamental theorem of calculus here, and I notice a couple things. One of them is that this by itself is an odd function. Secondly, that our limits of integration are equidistant from the origin. So that means using my properties of definite integrals, I can split up this definite integral to be the integral from -2 to 2 of x to the 7th dx plus the integral from -2 to 2 of k dx. Of course, together, don't forget the rest of the equation, that's going to equal 16. Let's keep writing everything there is so we don't forget. Now, because of this odd function with limits equidistant from the origin, this integral is just 0. This one I can evaluate using my fundamental theorem of calculus. K is a constant, so when I take its antiderivative, it becomes constant times x. Put my brackets to show I have to evaluate. Write the rest of the equation. Upper limit plugged in is k times 2 minus, then the lower limit plugged in, k times -2. Write the rest of the equation. This makes 2k plus 2k equals 16, or 4k equals 16, so k equals 4. Isn't that pretty neat? Let's take a look at an example where we're using the fundamental theorem of calculus. If f prime of x equals 2x plus 5 and f of 1 equals 6, find f of 3. So I notice that I have a derivative, and this one not a derivative. Still also this one not a derivative. Or we can think of it as anti-derivative of what we were given over here. Well, I remember the fundamental theorem of calculus tells me that the definite integral from a to b of a function, I'm going to use this f prime of x, equals its antiderivative, which would be normal f of x evaluated at the upper limit, minus f of x evaluated at the lower limit. I'm going to apply this fundamental theorem of calculus to our information. The definite integral of our f prime, which is 2x plus 5 dx, equals, now what limits do I use here? Well, I notice these x values that are used, so I'm going to plug them in here, and therefore it's going to equal f of 3 minus f of 1, because this part right here is f prime of x. Now I can use my fundamental theorem of calculus and take the antiderivative of what's here. So that's going to be x squared plus 5x. I put my brackets to show that I need to plug in the values. F of 3 is unknown, but f of 1 is a value they gave us. That value is 6. So I'm going to substitute f of 1 with 6. Now I plug in my values. This is 3 squared plus 5 times 3, and then I subtract with the lower limit plugged in, 1 squared plus 5 times 1 equals f of 3 minus f of 6. 9 plus 15 is 24, minus 1 plus 5 is 6, equals f of 3 minus, oh, whoops, I just realized I wrote f of 6 here instead of 6. Okay, so we'll fix that. And now I can solve for f of 3 by adding 6 to both sides, and f of 3 equals 24. Awesome! Thanks for watching.